Hello, welcome to this video. In this video, let us take one more problem on reciprocating compressor. A single cylinder double acting compressor. Remember, when we talk about double acting compressor, we will be writing this Vs as pi d square by 4 into length into n, but it has to be multiplied with 2. This we know, right? So, because for double acting cylinders, you know that the compression will be happening on both the sides. So, this is the first hint that whenever you encounter a problem on double acting cylinder, this we must take care of. Okay. So, because double acting cylinder and it delivers 100 meter cube per minute of air. So, the volume of air delivered is 100 meter cube per minute. Okay. Then mean piston speed. So, whenever piston speed is given, so piston speed is given 500 meter per minute. Remember, whenever piston speed is given, that is like linear velocity is given. We must know that whenever piston speed is given, imagine a piston and cylinder arrangement where we have a piston and cylinder like this. Then obviously this is connected to a device where you can convert this reciprocating into linear or linear to reciprocating, right. So, in this case actually rotary to linear is happening and we are interested in. So, you have this rotary motions here. So, we are interested in this is rotating at certain RPM and but we have been given with this speed. Okay. So, this is the speed of the piston. So, this is linear speed. Now, remember if this rotations half of the rotation, for half of the rotation I mean piston comes from this point 1 to point 2, I mean the rotation is from point 1 to point 2, this piston would have moved from TDC to BDC. Okay. So, that means for half of the rotation piston moves from here to here and for remaining half of the rotation piston moves from BDC to TDC. So, now therefore, piston speed if it is given in linear, then you know that it has to be 2 times of L into now into N. So, for every one revolution of this shaft, we will have 2 times of length moved, that is what it means. So, if you want to convert this into RPM, so therefore, N should be equal to piston speed by 2L, piston speed by 2L. So, this will have to do every time when we encounter the problem when speed is given in meter per minute. So, that is linear speed of piston is given. So, piston speed is given. So, I will say that N should be equal to now, N should be equal to piston speed by 2L. Okay. So, piston speed is given as 500 and let us keep this as 2L for now. Okay. Now, measured at 1 bar and 15 degrees Celsius. So, the pressure is given as 1 bar and temperature is given as 15 degrees Celsius. So, 15 plus 273 will have 288 Kelvin. Okay. The air is delivered at 7 bar. So, delivery pressure is given 7 bar, delivery pressure is 7 bar. Assume clearance volume. So, clearance volume is 1/15th of this swept volume per stroke. Yes, find the volumetric efficiency. Therefore, we will go for the first sub question. Find the volumetric efficiency and then speed and bore means diameter, stroke for following two cases. So, there are two cases. Now, let us take the first case. So, First case we will take on here. So, this is our first case. Okay. First case. So, for both case we will have to find out volumetric efficiency, speed, diameter and length. Now, first case is if ambient and suction conditions are same. So, that means ambient and suction conditions are same means we are talking about this Vs. I mean the volume of air delivered is there, no, that is the that is measured in ambient conditions. So, that itself will be effective swept volume, okay, because the air delivered, let us draw PV diagram. Let us draw PV diagram. So, we know that if we draw this PV diagram, we know that we are talking about a problem with clearance volume. So, with clearance volume means we will have compression from 1 to 2, then 2 to 3 is the air delivery, then 3 to 4 we are coming back to initial point, then 4 to 1 is your suction stroke. Okay. So, then effective swept volume will be V1 minus V4. So, that is the volume which is delivered. So, V1 minus V4. So, basically the Vs is given as 100 meter cube per minute. So, this is given as 100 meter cube per minute. So, Ves is given. So, this is our. So, why we did not write this in the first plans is because in the second case he has changed the suction conditions. So, in the second case this Vs will be different. Okay. So, effective swept volume is given. Now, let us solve this problem. Now, volumetric efficiency equation we already know. Volumetric efficiency is given by 1 minus C. Yeah, we missed out these parts like in the, at the last he has given take L by D is equal to 1.25. L by D is equal to 1.25, or you can write it like L is equal to 1.25 times of diameter, and small n, the index of compression is also given, that is 1.3. Okay. Now, volumetric efficiency is given by 1 minus C into Rp power 1 by n minus 1. Okay. Now, what is this C? C we already know, this C is nothing but Vc by Vs. So, we already know the value of C is Vc by Vs. So, that is already given. C Vc is equal to 1 by 15. So, that means C value is 1 by 15. Okay. And Rp also we can calculate here. Rp is pressure ratio P2 by P1. So, that is delivery by suction pressure. It is 7 bar divided by 1 bar. So, that is 7 into 10 power 5 and 10 power 5 cancels out. You can neglect that. So, Rp is given as 7. Okay. So, that means we can readily calculate this volumetric efficiency now 1 minus. Now, the value of C is 1 by 15 and this Rp is 7 power 1 by 1.3 minus 1. So, this will be our volumetric efficiency. Now, what is that? Let us calculate. 1 minus 1 by 15 into 7 power 1 by 1.3 minus 1. That will be 76.88 percentage. 76.88 percentage. So, multiply by 100 of course, that is when you get 76.88 percentage. Okay. So, once you have this volumetric efficiency, we can go on solving it further. So, volumetric efficiency is also given by the equation VES, that is effective swept volume divided by swept volume. Now, since you have this volumetric efficiency, I will write it as 0.7688 because I am not multiplying by 100 on the other side. It will be 0.7688 multiplied by, we can simplify this for effective swept volume. So, Vs will go to the other side. So, we can write effective swept volume can be written as 0.7688 swept volume. Okay. Now, this equation can be further solved. We will call this as equation 1. Now, how can we solve this? Now, we know the equation for this, that is 0.7688, because we know the value of V is 100 meter cube per minute from here. So, equation 1 can be solved. So, I will solve this equation 1, let us say solving equation 1. Now, left side is VES, that is 100. I will keep it in meter cube per minute only, not a problem, because right side also has to be made sure that it is in meter cube per minute. Now, VES is 100 meter cube per minute, and this side we have 0.7688 into Vs. Now, what is this Vs? Vs is swept volume. Now, swept volume is given by the equation pi d square by 4 into L into N. Okay. But we know that we are talking about double acting cylinder. So, this has to be multiplied by 2. Okay. Now, in the whole equation, if there is only one unknown, I think we can find it out. So, left side is meter cube per minute, and therefore, diameter and length here. So, this will be in meter cube. So, this will be in meter cube. If you substitute this n in RPM, then that will be in the meter cube per minute. So, the units are balanced, but however, we will have to make sure that the equation has got only one unknown. Now, how do we make that? Pi d square by, I mean, L is given in terms of diameter. See, L is 1.25 times of diameter. So, 1.25 times of diameter. So, this is 1.25 times of diameter, and N is given, N we have simplified, N is piston speed by length, like 500 divided by 2L we have done. So, this will be now this 4 is there only, this will be 500 by 2 times of L. Now, again L is I will simplify here only, otherwise. Now, 500 divided by 2 times of 1.25 times diameter, because you see L is 1.25 times of diameter again. So, I will write in place of N 500 by 2 into 1.25 d, 1.25 d, and this must be multiplied by the value 2. Now, you can simplify it like 1.25 d, 1.25 you can cancel out, 2 and 2 you can cancel out. So, we will remain with 0.7688 into pi d square by 4 into 500. So, the only unknown in this equation is diameter. I think we must be able to find out that the diameter value. Now, 100 is equal to 0.7688 multiplied by shift pi d square. So, I will call that as alpha x square, the unknown, pi d square divided by 4 multiplied by 500. So, I will close the bracket, the only unknown is shift, so I will go for 0. So, 0.5755 is our diameter, 0.5755 meter is our diameter. Now, L is equal to 1.25 times of the diameter. So, 1.25 into 0.5755, 1.25 into 0.5755 is 0.719, meter. So, that will be our stroke length. Okay. Now, let us go to the second part of the question. Now, what was our second part of the question? Second part of the question is where suction conditions are differ. Okay. Suction conditions differ. The second condition is given as, now our ambient suction conditions are different. So, suction pressure is 0.98 and 30 degrees Celsius. Now, this is 30 degrees Celsius, not 300 degrees Celsius, is 30 degrees Celsius. 0.98 bar and 30 degrees Celsius. 0.98 bar. So, P1 is then 0.98 bar and the temperature is 30 degrees Celsius. But our volume of free air delivered is given at different conditions. I will call it as some PF, VF. So, we know that we how to convert this volume into our required volume. So, PV PV by T is equal to constant, because PV by MRT, PV is equal to MRT. Now, PV by T is equal to MR, that will be constant. So, M and R are constant. So, PF VF by TF is equal to P. We are talking about now effective swept volume, that is V1 minus V4 will be different. So, T1. Now, what is our PF? PF and these are given. Now, our new P1 is 0.98 and this T1 is 30 plus 273, 303, okay, 303, and this is what we want. If you want to convert this into 10 power 5, okay, that is Newton per meter square. So, this is our effective swept volume. Similarly, this was given at different like this was given as 100 meter cube per minute, 100 meter cube per minute. I am not converting now because we will get the answer in meter cube per minute. Now, PF is I think 1 bar. So, we have been given with 1 bar and 15 degrees Celsius. Now, that was 1 bar. So, 1 into 10 power 5 if you want, and TF is 15 degrees Celsius. Now, 15 plus 273, 15 plus 273 is 288, 288 Kelvin. Now, let us solve this equation. 1 into 10 power 5 multiplied by 100 divided by 288 alpha equals, we have this 0.98 into 10 power 5 into the unknown is x divided by 303. Now, let us solve this, shift solve for x is equal to 0. We have 107.355. So, effective swept volume is 107.355 for the new condition. So, that will be of course meter cube per minute. Now, we will not worry about calculating volumetric efficiency, because volumetric efficiency does not change, because RP value changes. So, volumetric efficiency has to be recalculated. So, volumetric efficiency, let us recalculate. So, therefore, now volumetric efficiency is 1 minus C into Rp power 1 by n minus 1. Now, 1 minus this is same, C is same, Vc by Vs. Now, Rp is 7 bar, delivery pressure is same, whereas the P2 by P1. So, P1 is 0.98. So, this whole power 1 by n. Even if you put for this 10 power 5, it will be cancelled out. So, I am not substituting that value. So, volumetric efficiency, new volumetric efficiency will be 1 minus 1 by 15 multiplied by 7 by 0.98 to the power 1 by 1 by 1.3 minus 1. 76.416. 76.416 is our new volumetric efficiency. 76.416 percentage. Now we have got volumetric efficiency. Using this volumetric efficiency, let us go for the other equation which we have used. Now volumetric efficiency is given by effective swept volume divided by swept volume. Now volumetric efficiency is 0.76416 must be equal to effective swept volume is known to us, but let us write it this way, divided by Vs. Therefore, effective swept volume is given by 0.76416 swept volume. Now I call this as equation 2. Let us solve this equation 2. That is what we did in the last case also. Now effective swept volume is given. Now the new effective swept volume is 107.355 must be equal to 0.76416. Now the swept volume is pi d square by 4 into L into N. Okay. Now this has to be multiplied by 2 because it is double acting cylinders, right. So now the next part is L is equal to 1.25 d. So 0.76416 pi d square by 4. L is 1.25 times of diameter and N is same, like N we have solved 500 by 2 into 1.25 d. 500 by 2 into 1.25 d. 2 into 1.25 d and 2 here. Now 1.25 d, 1.25 d cancels out, 2 and 2 cancels out. We are remaining with this equation. So I think diameter is the only unknown. We must be able to calculate the diameter. Pi d square by 4 into 500. This is what is remaining now. So let us calculate this. 107.355 alpha equals 0.76416 multiplied by shift pi alpha x square pi d square divided by 4 into 500. Now we will solve for x is equal to solve for x is equal to 0. Now the diameter is 0.5981. So diameter is 0.5981 meter and length is 1.25 times the diameter. So that will be 1.25 into 0.5981. So 0.7476 meter. 0.7476. Now if you are talking about the second case where the suction conditions are different, this will be the diameter and length. All right. Now once we are done with this, we can also calculate, I think, speed. Now speed is what? Speed is given by N can also be calculated. Now speed equation is 500 by 2 into 1.25 times of diameter. 500 divided by 2 into 1.25 diameter. Now for the first case, speed is 500 divided by 1.25 2 into 1.25 times diameter. Diameter is 0.57. For the first case, 0.5755. Okay. So, 347.52 RPM, 347.52 RPM. So, this is the RPM for the first case. Similarly, let us go to the second case. Now, once we have this value, I think RPM n is equal to speed, n is equal to, that is 500, speed divided by 2 into ln. So, 1.25 times of diameter. Okay. Now, 500 by, for the second case, for the same piston speed, 2 into 1.25 times of diameter is 0.5981. So, that will be, I am just changing this, diameter is the only parameter which is changing, 0.5981. So, 334.39 RPM, 334.39 RPM. Okay. Thank you.